Now we are going to an important result. So the theorem says that when n is a positive integer, j minus mx, when n is a positive integer, then j minus mx is sigma n ranges from 0 to infinity minus 1 power n x by 2 all power 2n minus m all divided by n factorial into gamma minus m plus n plus 1 factorial. Gamma minus m plus n plus 1 factorial means it is minus m plus n, sorry, not a factorial, gamma minus m plus n plus 1. Gamma minus m plus n plus 1 means it is minus m plus n factorial. How to prove this one? So its proof is, what is m? Since m is positive, since m greater than 0, what is minus m plus n factorial? When n equals minus m plus n factorial, this goes to infinity. When n equals 0, 1, 2, etc. to m minus 1. Okay. So, when n equals 0, 1, 2, 3, etc. to m minus 1, minus m plus n factorial goes to 0 means 1 by minus m plus n factorial goes to 0. Agreed. That means 1 by gamma minus m plus n plus 1 goes to 0. Okay. M is positive and we know that minus m plus n factorial goes to infinity when n equals 0 up to m minus 1. So 1 by gamma of this quantity, gamma minus m plus n plus 1 goes to 0. Sure. Okay. Therefore, since this quantity goes to 0 when n ranges from 0 to m minus 1. So the first m terms, 0 to m minus 1, first m terms vanishes. So this can be rewritten as j minus mx equals sigma n ranges from m to infinity. Why? Because when n varies from 0 to m minus 1, that term does not, all of that terms are zeros. So it is not exist. Why? Because 1 by gamma minus m plus n plus 1 goes to 0. So that term should be vanishing. So j minus mx is that exists only when n ranges from where to where? M to infinity after m minus 1. So n ranges from m to infinity minus 1 to the power n x by 2 all to the power 2n minus m all divided by n factorial into gamma minus m plus n plus 1 or minus m plus n factorial. Agreed? You can replace. So now you can replace n by n plus n. You can replace n by n plus m. What it is? N by n plus m. So this become j minus mx is nothing but, if you replace n by n plus m, there is no change in this infinite sum. Why this sum? Why? Because the sum is infinite. So there is no change. So you can replace this n by n plus m. So then the sum again rearranged as n ranges from 0 to infinity. It is replaced n by n plus m. N equals m there. So the variation of n or the n ranges from where to where again from 0 to infinity. Minus 1 to the power n plus m into x by 2 all to the power n is replaced by n plus m. So 2n plus 2m minus m. Okay. So 2n, 2 into n plus m. 2 into n plus m minus m. 2n plus 2m minus m. It is 2n plus m. 2n plus m all by m plus n factorial into gamma. If you replace n by n plus m and m cancelling each other, so it is gamma n plus 1. Okay, gamma n plus 1 is nothing but n factorial. So that is, this can be again rearranged as, it is minus 1 power m into, what remains there? Sigma n ranges from 0 to infinity, minus 1 power n, x by 2 all power 2n plus m, all divided by n factorial, this is n factorial, into n plus m factorial. What is actually that sum? That is jmx. That equals minus 1 power m into jmx. So, j minus mx is equals, j minus mx equals minus 1 to the power m jmx. Okay. This happens when m is positive. When m is positive, then we know that j minus mx is minus 1 power m jx. Okay. When m is positive, we know that there is a result, j minus mx equals minus 1 to the power m jx. So it's a first result. Suppose m is negative. Put m is negative. If m is negative. When m is negative, then let p be a positive. Choose p. Choose p be a positive integer such that n equals minus p. M is negative. And you can choose p is a positive integer in such a way that n equals minus p. When m is a positive integer, when m is positive, j minus mx is minus 1 power m jmx. Here we know that p is positive integer, whatever may be, since p is positive. So according to that idea, or in the light of that argument, we know that j minus px is minus 1 to the power p jpx. When m is positive, we see j minus mx is minus 1 power m jmx. Here we choose p is a positive integer. Whatever maybe it has positive characteristic, so it is a positive behavior. So it is j minus px is minus 1 power p jpx. Enough. So from here, what is jpx? Jpx is minus 1 power minus p j minus px. Jpx is minus 1 power minus p j minus px. But what is minus p? That is n. Okay, so it is what is p? P equals minus n. So this gives, according to this choice, we choose p is a positive integer with n is minus p. Since p is minus n, so this result will become j minus nx. You can replace n by minus, or p by minus n. J minus nx equals minus 1 to the power. What is minus p? N. Minus 1 to the power j minus p means jx. So when m is positive, we see j minus mx is minus 1 power m jmx. And when m is negative also, j minus nx is minus 1 power n jx. So this is the important result. Here we know that when n is an integer, positive integer, here this is our case, when n is a positive integer. When n is a positive integer, jnx and j minus nx are related by this way. Means one is a constant multiple of other. In previous case we know that j minus px and jpx are not constant multiples of other. Why? Because one is finite and other is infinite. So they becomes the linear independent solutions of Bessel equation. One is known as Bessel function of first kind, other is Bessel function of second kind. But when n is a positive integer, here we see that j nx and j minus nx are related by this way. That is, j minus nx is minus 1 power n j nx, means one is a constant multiple of other. That means they are not linearly independent, means they are linearly dependent. So this is the important result. When n is an integer, moreover it's a positive integer, then j minus nx and j nx are linearly dependent. When they are not linearly independent, means they are linearly